In the last video, we tried to figure out if it was possible to use images instead of loris to create multiple consistent characters in a single image. And the verdict is, not really. But maybe. If you already know the exact composition of your image, you might be able to make it work with PoolID's attention masking. I said I'd go through the different image to character options and see if there's actually something that can do this. But as always, working with Comfy sent me spiraling down a rabbit hole of spaghetti-filled madness. And honestly, I think I finally understand why these nodes even exist. So today we're diving into 4 different nodes and their workflows: PoolID, Ace++, FluxFill, and FluxRedux. I'm going to use these to create an AI influencer, and then we'll use that influencer to test everything. Before we get into it, don't forget to like and subscribe for more deep dive videos like this one. It really helps with my sanity. Okay, so here's the set of workflows we're working with today. Let's start with the default Flux workflow. I want to create 2 portraits, one female and one male. Each of these workflows comes with its own loader group, where you can choose between GGUF or FP8 for both the checkpoint and clip models. If you want GGUF, that's option 1, FP8 is option 2. And the workflows are all linked to their loaders through Set and Get Nodes. If you find a workflow you like and want to copy it into another tab, here's how. Highlight the entire workflow. Press Ctrl+C to copy, then open a new tab by clicking the plus icon. Once you're in that new tab, just paste it in. And there you go. Your workflow is ready to use. Now, if you want to save it so it's always available next time you open Comfy, click Workflow, then Save As, give it a name, and you're set. On the left side of each workflow, there's a group by parser, which makes selecting workflows easier. Plus there's a note listing all the models that particular workflow needs. Back to what we were doing. Creating the models we'll use to test everything out. For LoRa's, I'm using Turbo LoRa and Super Realism LoRa. The weight is set to 1, CFG is at 4, and we're running it at 16 steps. The first model will use this prompt. The trigger word is Super Realism, and make sure all the other groups are turned off. Here's the full prompt. Super Realism, a hyper-realistic portrait of a stunning brunette woman with silky, flowing hair and vibrant, multicolored highlights that shimmer in the light. Her piercing eyes gaze directly into the camera, reflecting depth and intensity. She's positioned perpendicular to the camera. The plain background is softly blurred, emphasizing her flawless complexion, full lips, and delicate features. The lighting is a perfect balance of soft and natural, casting subtle highlights and shadows that enhance her facial contours. Shot with a Canon R5 85mm f1.2 lens for a dreamy bokeh effect. The atmosphere is elegant and captivating, evoking a sense of mystery and allure. Okay, this looks way too modelly. Let's tweak it a bit. This time, I'm adding with speckles on her face, and I'm also lowering the CFG to 2.7. Much better. Alright, next up is the male model. Here's the prompt I'm using. A hyperrealistic studio portrait of a handsome male model standing with his body perpendicular to the camera while gazing directly into the lens. His chiseled jawline, high cheekbones, and deep set, piercing blue eyes exude confidence and charisma. His short, neatly styled hair has a slight shine, and his light stubble adds ruggedness to his otherwise smooth complexion. The background is a soft, neutral gray, ensuring complete focus on his features. Shot with a Canon EOS R5 85mm f1.2 lens at f1.8 aperture for a shallow depth of field, blurring the background while keeping his face in ultra-sharp focus. Soft, directional Rembrandt lighting enhances the contours of his face, casting subtle shadows for depth and dimension. His expression is poised yet enigmatic, making the portrait feel both intimate and commanding. Okay, now that we have both portraits, let's see if we can use them in PoolID to create consistent characters in different locations, doing different activities. First, we need to deactivate the Flux workflow and activate the PoolID workflow. To do that, find PoolID in the group by parser, then click on the little arrow next to it to expand the workflow. Now, what I really want to test here is whether we can get consistent images just from these 2 portraits. Nothing extra, no additional training, just the models we already generated. This version of PoolID is a lot more efficient than previous ones, so just make sure you don't have any old Flux PoolID versions installed. If you do, go ahead and remove them first. This version also uses Tcache and wave speed for faster processing, plus an attention mask that helps us place the characters exactly where we want them. I'm going to upload both models and use this scene as a test. A hyper-realistic nightclub scene featuring a man and woman on the dance floor, illuminated by vibrant neon lights. The woman, with long flowing hair, a fitted red dress, and high heels, moves gracefully with a confident smile, while the man, wearing a stylish black button-up shirt and tailored pants, leads with charisma. The background is filled with colorful beams of light, blurred silhouettes of other dancers, and a glowing LED DJ booth. Shot using a Sony A7R 35mm f1.4 lens with a wide aperture and slow shutter speed to capture the dynamic lighting and motion blur of the surrounding club. The atmosphere is electronic, with cool blue and magenta lights reflecting off their skin, creating a cinematic, high-energy aesthetic. Before I cue it up, I need to make sure the base Flux Dev model is selected. We got exactly what we asked for, but using the models we created earlier, you can do the same thing, even with just one image, and you'll still get a consistent result throughout. To test that, I'm going to disable the male image and place just the woman in a completely different environment. This time I'll use this prompt. A stunning, hyper-realistic beachside image of a beautiful woman standing on soft golden sand, licking a colorful spiral lollipop. She wears a red swimwear top and a vibrant, tropical patterned miniskirt that sways slightly in the ocean breeze. Her long, sun-kissed hair cascades over her shoulders, catching the warm glow of the golden hour sunlight. The background features a crystal-clear turquoise ocean, gentle waves rolling onto the shore, and a few blurred figures enjoying the beach. The lighting is warm and natural, enhancing the radiant glow of her tanned skin. Captured with a Sony A7R 85mm f1.4 lens, shallow depth of field f2.0 to emphasize her facial features and the playful expression in her eyes as she enjoys the candy. The scene is both vibrant and effortlessly glamorous, evoking a carefree summer mood. Before running it, I'm also making a few adjustments. I'm disabling the turbo LoRa and increasing the steps to 25 just to see if we can get a sharper, more refined image. Let's check the result. Okay, it's good, but I actually need a full body shot. So I'm going to go back and modify the prompt by adding full body and also removing the lollipop. That looks way better, and this is important because we'll need her upper body for the next few tests. Alright, let's do the same thing with the male model. Here's the prompt I'm using, a hyper-realistic medium shot of a stylish man leaning casually against a street sign in the heart of a bustling city. He wears a well-fitted leather jacket over a white t-shirt, paired with dark jeans and sleek sneakers. His expression is confident yet relaxed as he gazes into the distance. The background is filled with neon lights reflecting off wet pavement, blurred figures of pedestrians walking past, and distant skyscrapers illuminated by the evening glow. The atmosphere is dynamic with a sense of movement and energy. Shot with a Canon R5 50mm f1.2 lens, aperture f1.8, using a shallow depth of field to keep the man sharply in focus while the background blurs into a cinematic cityscape. The ambient lighting from streetlights and storefronts casts a soft glow on his face, creating a moody, atmospheric effect. You can already see how powerful Pull ID is, especially if your goal is to create consistent and convincing AI influencers. And later on, I'll show you how to use Pull ID with another tool to give you even more control over what you generate. Next, we've got Ace++. Now, Ace is a new addition to this group of face swap, clothing swap, and object swap nodes. So before we do anything, the first step is to disable the Pull ID workflow and enable Ace++. Just make sure you turn off Pull ID first. Ace++ works a little differently from what we've been using so far. It has two main image inputs. The first image is the one you want to edit, meaning whatever changes we make will show up here. The second image is called the driving image, which means this is the image that provides the new element, whether it's a face, clothing, or an object that will be applied to the first image. Ace++ also uses three different LoRa's: the local LoRa, the portrait LoRa, and the subject LoRa. What makes Ace really interesting is that it combines LoRa's and input images, so it has a lot of different use cases. From what I've seen, it's amazing for AI influencers, e-commerce prototyping, mock-ups, and even some advanced editing. At least when it works. And I have to be honest, sometimes it works perfectly, and other times it just refuses to do anything. But to be fair, the developers have already said that it's not a final product, so that's expected. Okay, let's try it out. First, we need to activate the subject LoRa. Then, we're going to upload the female model's image into the first upload slot. That's the base image we're editing. In the second upload slot, we'll upload the driving image, which is the reference for what we're changing. For this example, I'm going to swap out her top for something completely different. To make sure the change applies correctly, I'll mask just her upper body. And the way the prompting works here is pretty simple. You just describe what you want to see. So in this case, I'll use a prompt like, "The woman is wearing this shirt." And the word "this" refers to the driving image with the shirt I want to apply. Sometimes that works right away. Other times it doesn't. If it doesn't, you might have to be more specific in your description. A couple of settings to check before we run this. Make sure you're using the fill model, set masking to 2, and bump the CFG to 50. That might seem a little high, but that's just how FluxFill seem to like it. Alright, let's see what we get. Yeah, like I said, when it works, it really works, and when it doesn't, you get this. But let's try again. This time, I'll add a bit more detail and specify that I want a short sleeve shirt. And there we go. That's exactly what I was going for. Now, this is a total game changer if you're running an e-commerce shop, especially if you're selling a lot of clothing. Instead of setting up multiple photo shoots, you can just create a few AI models and swap out different outfits as needed. But, like I mentioned earlier, ACE++ doesn't always give you perfectly accurate results. The clothing will look similar, but it might not be exact. There's actually another workflow that's a little more precise when it comes to clothing swaps. And we'll take a look at that later. Now let's do the same thing, but this time using auto select. I've got this image loaded, and for the driver, I'm going to use the sneaky robot logo. First, switch the mask mode to 1 for auto select. Then, in the Florence node, type coffee mug. That's how we tell it what to modify. The full prompt I'm using here is display the logo on a white coffee mug. This is exactly why ACE++ is great for mock-ups and prototyping. You can take any product, slap a logo on it, and see how it looked before anything gets printed or manufactured. Before we keep going, I want to quickly explain something. The model we're using is the Flux Dev Fill model, and the CFG is set a little higher than usual, at 50. That's intentional because it helps keep the generated output more controlled. I'm also using Tcache for extra speed, but if you prefer, you can use wave speed. It works just fine too. Next, I'm switching to the portrait LoRa. To do that, I'm going to deactivate the subject LoRa and activate the portrait LoRa instead. Now, for this test, I'll upload a portrait of a woman as the base image, the one we're editing. Then, for the driving image, I'll upload a portrait of a male model. This time, I'm going to manually mask the woman's face and use a simple prompt. The man is smiling. And what that's going to do is swap out the masked area. So in this case, it'll replace her face with his. And there you go, a face swap. There's a lot you can do with ACE++. You can load a product, upload a logo, and instantly get a mock-up of what it'll look like in real life. It's super flexible, and honestly, the possibilities here are huge. Now let's move on to Flux Redux. This setup actually consists of 3 Redux groups and 1 conditioning and sampling group. What Redux does is take an image and create different variations of it. It looks at the image, analyzes it, and then uses it as a kind of prompt guide. The models being used here are the Flux Dev model, the SICK Clip Vision model, and the Redux model. There's also an advanced Redux Flux Control node, which lets you either increase or decrease how much influence the original image has over the final output. So let's try it out. I'll load an image I created for a previous video. Before writing the prompt, I'm going to disable the other 2 Redux groups so I can focus on just one. Now for the prompt, I'll go with 80s style anime. And I'm making sure that my image strength is set to medium. Let's see what we get. So the result keeps the overall structure of the original image, but adds that 80s anime style I asked for. And the way this works is pretty interesting. The image strength setting controls how much the final image sticks to the original. If I had set it higher, the output would have been more realistic. Lower, and it would have leaned more into the anime look. What's really cool is that you can daisy chain up to 3 Redux groups in a row to create something even more complex. Let's try it. For image 1, I'll add our influencer at medium strength. Then for image 2, I'll add a snowy background, also at medium. Right now, I'm only using 2 Redux groups, and I'll leave the prompt empty for this test. Let's see what we get. Okay, so it changed the model's face way too much. That means the image strength is probably too low. Let's crank it up to high and try again. Yeah, that's better. The second Redux group isn't as heavily influenced now, but let's fine-tune it even more. This time, I'll set the prompt to woman standing in a snowy walkway. That looks a lot closer to what I wanted. Now, you can also mask just part of the image and apply Redux only to that section. Let's activate the third Redux node. And I'll mask this part of the image so only that area is affected. And this is where Redux really shines. There is so much you can do with it. Try out different combinations, swap backgrounds, and basically place your AI influencer anywhere in the world. Just one important thing to remember. Redux works best with square images. If you use anything that's not a square, the results won't be as good. Let's look at the next workflow. This time, we're using Redux and Pool ID together. This workflow combines the Flux Dev model with Pool ID, SickClip, and Redux models. And it's perfect if you have an outfit worn by someone else and want to apply it to a different model. Here's what I'll do. First, I'll load an image of a woman wearing a designer jacket into the Load Image node. Then I'll add my AI model to the Pool ID node. I'm going to leave the prompt empty since Redux will handle that part for me. Let's see what we get. Okay, so this is interesting. It's a little desaturated, and the jacket isn't an exact match. That means the image strength is probably off. Let me try reducing it and see if that helps. Alright, here's the new result. I actually think that the first one was better. I think instead of lowering the image strength, I should have increased it. Let's test that. Yep, way better. So, what can I say? This setup is insanely useful for e-commerce, AI influencers, and even just experimenting with different outfits in a super realistic way. The last workflow we're going over today is the Change Clothes workflow. This one is kind of like the ACE workflow, but without the LoRa's. Instead, it relies on auto-masking and manual masking, and it uses the Flux Fill model for in-painting. Then it combines the Redux and SickClip models to pick up the image of the clothing and generate a prompt for it automatically. So let's set it up. First, I'm going to upload an image of a t-shirt into the Load Image node. This will be the clothing we want to apply. Then, in the second Load Image node, I'll upload the image of the model, which is the person wearing the outfit. Next, I need to mask out the model's torso. This is the area where the new clothing will be applied. Since I'm doing this manually, I'm making sure the mask switch is set to 2. Now, here's the interesting part. We don't actually need to write a prompt for this. Because we're using Flux Redux, it's going to take the image of the t-shirt, create a variation of it, and then seamlessly apply it to the model. That means it automatically understands what the clothing looks like and makes it fit the person wearing it. This workflow is super flexible, and the results can be surprisingly good. If you want to test out different outfit ideas without manually writing prompts, this is definitely something to try. So those are the workflows. Go through them, see which one works best for what you need, and let me know if you've come across any other workflows like these. Also, I'd love to hear what you think they're best used for. Personally, I think ACE++ has a ton of potential. I just need to get the rest of it working exactly how I want. There's honestly so much it can do, especially when you combine it with the Photopea node. Alright, let's get this installed. There's a few models you need for the workflows. Let's start with the ones you can install through the Comfyui manager. Open up the manager and go to the Model Manager. We'll start with Flux. If you've already got Flux installed, you can skip this part. For the Flux FP8 model, in the first drop-down, select Checkpoint. In the second drop-down, choose Flux 1, and then click Install for the Flux 1 Dev FP8 model. If you're installing the GGUF version, in the first drop-down, select Diffusion model, and for the base, choose Flux 1. Scroll down, pick the version you want. I use the Q4 version, and install that. Next up, the T5 clip encoder. In the Type drop-down, select Clip, and for the base, choose T5. Then, select the second FP8 version and click Install. If you're on a slower PC, scroll down until you see the GGUF versions and install the one you prefer. For ClipL, change the type to Clip Vision, set the base to VitL, and install the first option. For the VAE, set type to VAE, and for the base, select Flux 1, then install the VAE model. Now we need the Clip Vision model for Redux. Start by selecting Clip Vision as the type. Then for the base, choose SickClip and install that. For Pool ID, set type to Pool ID, choose Flux 1 as the base and click Install. That's everything from the Model Manager. Let's move on to manual installation. First up, the Flux Fill model. Click the link in the description to head over to Civit AI. Then download the model and save it in the Diffusion Models folder. If you're using a lower spec PC, you'll need the GGUF version. Click the link in the description, download the version you want, and place it in the Models UNet folder. For Redux, click the link in the description, download the file, and place it in the Models Style Models folder. Same process for Flux Turbo. Download it, place it in the Models LoRa folder, but before you do that, make sure to rename the file. Next is the Super Realism LoRa. Download it and put it in the Models LoRa folder. And finally, the Ace Loris. Click the links in the description. Download them and place them in the Models LoRa folder. To keep things organized, I recommend creating a new folder inside the LoRa folder and naming it Ace. That's all for the models. The rest will auto-download the first time you run the workflows. Now restart Comfyui and open the manager again. This time go to Custom Node Manager and search for Comfyui Patches 2. Install it. This patch allows Pool ID to use Tcache and wave speed. Restart Comfyui again. This time, drag the workflow into the workspace. If you get an error saying there are missing nodes, open the manager, go to Install Missing Custom Nodes, select the missing nodes, and click Install. Restart one more time, and that's basically it. Just make sure you're only downloading the models you don't already have, and you're good to go. If you've made it this far in the video, thank you so much for watching. I really appreciate it. If you found this helpful, don't forget to like, share, and subscribe for more, and I'll see you in the next one.